Hello, so today we are going to do this problem, which is part of today's contest, removing stars from a string. So the problem says we get a string S that contains stars, and in one operation we can choose a star in S and remove the closest non-star character to its left. So you can think of it basically as a backspace in when you are typing, where it deletes the character you typed before, right? And removes, of course, the star itself as well. And what we want to do is basically execute all these stars removal and then return the string after removing all stars and applying this this formula here, right? And let's take a look at this example here. So we have this star, which means we delete it and delete the left to it. So we delete this. We have these two stars, which means we delete these two. And so we end up with L-E-C-O-E, right? If we take a look here, we have 1, 2, 3, 4, 5 stars. So we need to delete all 5, right? So we end up with empty string. Yeah, so that's pretty much the problem. Now let's see how we can solve it. So you could definitely just go right to left, and every time you see a star, mark that you need to remove the next character, and just have a result string that you only add if the things, the count of letters that we still need to remove is equal to 0, right? So you could just go to right to left, and here to remove equal to 0 initially, so E is valid, so we add E. And then we find a star, so we need to remove 1, so we count that we need to remove 1, and we don't add a star to our result. And now what we want to remove, 1 character, and so we don't add this. And then we found D. We have a count of something to remove, so we don't add D, and this is now 0 for what we need to remove. And then O, this is equal to 0, so we add it to our result. Same thing, C equal to 0, so we add it to our result. So you get the idea. Basically, you just keep a counter of the letters that we need to remove, and as you go right to left, if you don't need to remove it, add it to the result, and at the end, just return it. So that's one way to do it. But if you kind of think about this, what we are doing right to actually here is just you can think of this actually in a different way, where you can use a stack instead. So we add we add L-E-E-T to our stack, and when we found the star, we just continue popping, because with the stack, the first in, last out, right? And so last in, that's the first out, which means when we encounter this star, we remove the last in, which is this T. So that's what we want. And then we encounter the second star, so we remove the last in after that, so we pop this. So it really this problem really is basically just a straight application of stack. So let's do it. So what we need to do is first, we need our stack, of course, right? So let's just create stack here, right? And then we'll go through the string. Now, if it's different, it's not a star, let's just add it to our stack. But if it's a star, that means we need to remove the last element that we added to the stack, and that's just stack pop, right? Which means basically, let's take this here, right? So we have our stack here, and we have our pointer, so we are at L. It's a letter, it's not a star, so we add it to our stack. We move the pointer, it's an E, so we add it to our stack. We move our pointer again, this is an E, and then we add T, and now we encounter a star. So we pop the last element we added, and that's exactly what the problem asks us to do, right? And then we found another star, so we pop this one. And so we ended up removing TE, and that's exactly what we want. And then we advance, we have C, advance again, we have O, advance again, advance again, we have D. One more time, now we have a star, so we need to pop the latest one, and that's exactly what we want. We want to remove this. And then we advance to E. And now we are done, so we just need to reconstruct this. And this is pretty much, since our stack is a list, it's actually like this, C, O, E. So we can just join these with an empty string, and we'll get the result, right? And so that's exactly what we are doing here. And now at the end, we just join what's in that list and return it. So let's run this and submit. Okay, so that passes test cases. Yeah, so in terms of time complexity, this is O(n) here, n being the length of S. And in terms of space, we are also using O(n) space because we are using the stack, right? Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.